Okay, so I want to go over graphing linear inequalities. There's two parts to this notes. Both of these notes you can find in your week 4-4 resources. So go ahead and pause the video if you need to and print those out so you have something to go along with. But I'm going to kind of quickly go through this. I'm actually going to skip the first example. I think that'll be more confusing after what we did today. I think you'll be ready to go ahead and go on to example 2. But basically, we're just going to walk step by step through a lot of the stuff that we explored today in class. But I want to go ahead and put notes to what we explore. So this will be helpful to you, I believe. All right, so let's just jump right in. It says graph y is less than or equal to 2x minus 3. Okay, well, let's go ahead and graph it. If you remember, and if you need to go back to the video on how to graph or your notes on how to graph, get those out. Just kind of pay attention to how I graph. A lot of this is going to take in stuff that we've done in the past and just add a little element of the inequality. So the first thing I'm going to do is I'm going to identify my y-intercept, which is b equals -3. Okay, and then I'm going to go ahead and graph -3 on my y-intercept, which is my y-axis. Go to -3. So here's 0, 1, 2, 3. There's -3. I'm going to plot my point. Okay. Now, I'm going to identify my slope. My slope is m equals 2. Now, of course, when we're graphing, in order to use for graphing, I need to turn it into a fraction. So I just take any whole number and stick it over 1. So now I have my rise over run. And then again, from my y-intercept, I'm going to go up 2, 1, 2, over 1, and plot my point. Okay, I'm going to do it again because my points are so close together. I'm going to do it again so I make another point. So up 2, 1, 2, over 1. Now because I'm dealing with, and we learned this today in class, I'm dealing with an equal to. It's y is less than or equal to, because it has that mustache or the equal to sign there. I'm going to go ahead and draw a solid line through my points. And again, your graph of your line should always extend through the length of your graph, and go ahead and put arrows at the end. It's signifying that it is infinite. Okay? Now, based on this equation, or sorry, inequality, it's not an equation. Based on this inequality, I'm going to answer these questions. What would the graph look like for y is less than or equal to 2x minus 3? Well, it would have a solid line, and it would be shaded above. And when we talk about shading above, we're talking about shading above the y-intercept. If you look at the y-intercept, that's what we're looking at, and we shade above that. That's all these numbers over here. I'm not going to do it because we have a couple of different examples. Okay, what if I had y is greater than? Again, all this is based on the y. Okay, this is based on the location of the y variable. Okay? So what if I had y is greater than, oh, I'm sorry, this is less than. I just said above. I am completely wrong. Let me go back. I am sorry. I think I do that once a video. Y is less than, that is below the y-intercept. So that's going to be down here. So I'm going to shade below. Excuse me. Or under. So that would be down here. Okay, if I graph y is greater than or equal to 2x minus 3, okay, again, I would have a solid line because of the line there. That's my indicator. A little mustache, right? And then because it is greater than, the y is over here, assuming the y is over here. Here the y is here. You got the y here. So y is greater than, pointing to the open side is pointing to the y. I would shade above. And then here, y is less than. Okay, now I don't have a mustache, so I'm going to have a dashed or dotted line. And because it's just less than, not equal to, but less than, I'm going to shade below the y-intercept. And then here, y is greater than, just greater than, not equal to. And since I don't have the equal to, I'm going to write a dashed line. And I'm going to shade, because it's greater than, above the y-intercept, which would be over here. All right. Let's go ahead and get right to the next one. So we're going to graph these. We're going to graph these inequalities, and then we are going to decide if the points are in the solution set or not. Okay? Well, if we look at our very first one, we see that it's not in y equals mx plus b form. So I need to put that into y equals mx plus b. So I need to solve for y. So the first thing I'm going to do is get y by itself. I'm going to add 2x to both sides. This is just like solving an equation. This is just like putting into y equals mx plus b, but we're going to have y equals mx something b. Okay? Now, bring down my 3y. This cancels. I have 3y is greater than. Put that 2x in front. 2x plus 6, because that's a positive 6. Get rid of that 3. Divide both sides by 3. This cancels, leaving me with y is greater than. I didn't have to flip my sign because I divided by a positive, so it's greater than 2/3 x plus 2. Okay? You should be able to know how to do this just from solving for y when we did the equations. Okay? So now let's graph this. Again, identify my y-intercept, which is b. b equals positive 2. So go to positive 2 on my graph on the y-axis. 1, 2. Plot a point. Now I need to identify my slope, which is 2/3. It's already in. Rise over run. So now I can go from my y-intercept and go up to 1, 2 over 3. 1, 2, 3. Go ahead and do another one. Up to 1, 2 over 3. 1, 2, 3. You should have a nice straight line. So go ahead and draw your line through the graph. Now if you notice, this is a greater than sign, so I don't have equal to, so I need to have dashes. And sometimes, if we forget, the easiest thing to do is just simply erase just pieces of it. Make sure you do it good enough so we can tell that you made a dashed line. So, here's my dashed line. All right. Y is greater than. Okay, I'm going to go ahead and highlight this right here or box this so we can see the equation. Y is greater than. So I mean I need to shade above my y-intercept. Here's my y-intercept, so I need to shade above. So I'm just going to simply shade right here. Okay? And there I have my inequality graphed. Now I want to determine if these points are part of the solution. So all I'm going to do is graph the points. So go to -2 over, so -1, 2, and up to 1, 2. There's the point. Is it part of the shaded area? It is, so yes, it is a solution. Okay, 3 and 4. Go over 3, 1, 2, 3. Up 4, 1, 2, 3, 4. That is on the line. Is it part of the solution? No, it is not, because it cannot be equal to. It's got to be in the shaded region. And then 0, 0, of course, is our origin. Is it part of the solution? Nope, it's not in the shaded area. So it is not part of our solution. All right, moving right along. Let's solve this one for y. I got to subtract x from both sides to get y by itself. Now I have negative 3y is greater than or equal to negative x minus 6. Divide everything by negative 3 to get rid of that negative 3. This cancels, leaving me with y. Now I divided by a negative, so I need to flip the sign. Is less than or equal to negative over negative is positive x over 3. Negative 6 divided by a negative 3 is a positive 2. So our inequality, our new inequality is y is less than or equal to x divided by 3 plus 2. So let's graph this. First thing I want to identify is my y-intercept, which is a positive 2 again. So I'm going to plot my point on my y-intercept, on my y-axis. So identify my slope. Now x over 3 is the same thing as saying 1/3 x. So my slope would then be 1/3. And again, I already set up for my rise over run. So for my y-intercept, I'm going to go up 1 over 1, 2, 3. Do it again. Up 1 over 1, 2, 3. And now I have my dots. So I can go ahead and graph my line. Pay close attention. Because we are equal to, we're going to go ahead and draw a solid line. Again, make sure it extends through the graph. Put your arrows on it so you show that it's infinite. Now, because now if we look at our equation, look down here, don't look up here, look where we solved, we have y is less than or equal to. So because y is less than, we shade below the y-intercept. Here's our y-intercept, so I need to shade down here. Okay, and then I need to plot these points to see if they are in the solution. So go over negative 3. 1, 2, 3, and up 1. Okay, that point is on the line. Is that part of our solution? In this case, because it's equal to, it is part of our solution. So we would say yes. Let's go over 0, x value 0, and up 4. 1, 2, 3, 4. Is that part of our solution? No. It is outside of our line, outside of our shaded region. Okay, the origin, 0, 0. Is that part of our solution? Yes, it's in that shaded region, so it is part of our solution. Okay? Moving right along. Whenever I graph y is greater than or 3, okay, what do we notice? We don't have an x, which means we don't have a slope, which means we just go to 3 on the y-axis. That's our y-intercept. And we should have this memorized from the last unit, and we graph a horizontal line. Now, is this a solid or dotted line? That's right. Doesn't have an equal to sign, so it's a dashed line. Make sure it extends all the way across your graph. It's hard to tell it's a dashed line on my picture there a little bit because it kind of blends in with the other grid lines. But that is a dashed line. Now I'm graphing above. I'm shading above because it is greater than. So I'm shading above the y-intercept. Well, here's my y-intercept. Above is up here. All these. So that is my shaded inequality. So let's find the point. 1, 3. Is that part of our solution? Go over 1, up 3. 1, 2, 3. It's on the line. Is that part of our solution? No, because it does not have equal to. Since it doesn't have an equal to, if it's on the line, it's not part of the solution. Okay, what about negative 3, 6? So negative 3, 1, 2, 3, up 6. 1, 2, 3, 4, 5, 6. Is that part of the solution? Absolutely. It's in the shaded region. And the origin, is that part of our solution? No, it's not in the shaded region, so it's not part of our solution. Okay. Now this one we had y is greater than 3. This one we have x. So if this was a horizontal line, the opposite of a horizontal line with the x is going to be a vertical line going through -4. So go to your x value, -4. 1, 2, 3, 4. Again, you should have had this memorized from the beginning of the first semester stuff that we've done, the equations. And now I'm going to draw, because it's equal to, I'm going to draw a solid line through the -4 on the x-axis. Okay? Now, this is the only time you're going to have to deal with left and right. If you use your common sense here, this will make it easier for you. And this is based on where the x is. It says x values are less than -4. Well, which way is less than -4? If you look at your number line, this is my x, and this is like a number line. All these numbers on the x are getting bigger. They are greater than -4. So all these values are less than. So that's common sense. We need to shade on the left side. Again, you can also look at the arrow on this one because this is a unique situation. If I look at the arrow shows I'm going to point to the left side, so I would graph on the left side or shade on the left side. So let's check these points. -4 over, 1, 2, 3, 4, up, -2 down, 1, 2. That point is on the line. Is it part of the solution? Yes, because we have a equal to sign, so it is part of the solution. 6 over, 1, 2, 3, 4, 5, 6, 1 up. Is that part of the solution? No, that's way away. -6 over, 1, 2, 3, 4, 5, 6, down -1. Is that part of the solution? Absolutely. It is in the shaded region. So again, what you should have learned from all this is a review of kind of how to graph, and that your solutions are going to be in that shaded region. Okay? And sometimes your solution will be on the line if you have an equal to sign. If you don't have an equal to sign, and it's just a greater than or less than sign, your solutions cannot be on the line. All right? Let's look at example 7. Okay, we're going to do this algebraically. Which of the following points would be solutions to the inequality y is greater than 2/3 x plus 2? Well, the way that we can do this algebraically is say, okay, let's plug in 6 and 0. So we're going to plug in 0 for y, because this is x and y. So I have 0 is greater than 2/3 times x, which is 6, plus 2. And I just simplified down as far as I can go. So I have 0 is greater than 2/3 times 6 is 2 times 6 is 12. 12 divided by 3 is 4, plus 2. Is 0 greater than 4 plus 2, which is 6? Is 0 greater than 6? Is that statement true? 0 is greater than 6? No, it's not true. So this is not a solution. Let's look at this one. 8, it's my x value, my y value. 8 is replacing that, is greater than 2/3 times 3, okay, plus 2. Go ahead and simplify. When you have 2/3 times the whole number 3, these are just going to cancel out. So 8 is greater than 2 plus 2. 8 is greater than 4. Is that statement true? Absolutely. 8 is definitely greater than 4. So this is a solution. Next one. -2, again, x and y, is greater than 2/3 times -6 plus 2. Simplify. -2 is greater than 2 times -6 is -12. -12 divided by 3 is -4 plus 2. -2 is greater than -4 plus 2 is -2. Is -2 greater than -2? No. Be careful. That seems to trick people up. But it is not greater than. It is the same, but not greater than. So that is not a solution. Let's do 0 is greater than 2/3 times -6 plus 2. 0 is greater than 2 times -6 is -12. -12 divided by 3 is -4 plus 2. 0 is greater than negative 4 plus 2 is negative 2. Is 0 greater than negative 2? Is that statement true? It is. So my solution is negative 6 and 0. That is a solution. Last but not least, negative 3 is greater than 2/3 x plus 2. Negative 3 is greater than, I put 2/3 x. Sorry, I should have got distracted for a second. Should have put negative 9 here. So 2 times negative 9 is negative 18. Negative 18 divided by 3 is negative 6. So negative 3 is greater than negative 6 plus 2. Negative 3 is greater than negative 6 plus 2 is negative 4. Is negative 3 greater than negative 4? Yes, it is. So that is one of our solutions. So that's how you figure out if an answer is a solution based on algebraically. You want to do this instead of graphing. If it gives you a number and says, hey, see if this is a solution, then do it algebraically. You don't want to graph all that just to plot one point. Just plug it in and see if it works. All right, moving on. Okay, this is the part 2 notes. Hopefully you've already printed these out. If not, pause the video so you can get the part 2 notes printed off so we can use these. Now, it's kind of giving you steps in part 2. We've already gone through the steps, but this is kind of reinforcing the steps we've already talked about. So the steps to solve or to graphing a linear equality is solve for y if necessary, plot the slope and the y-intercept. We did that. Usually it should be really reversed. Plot the y-intercept and then the slope. Okay? And then it says if y is less than or equal to, you draw a solid, and this is a little repeat from the other notes, a solid line through the point and shade below because y is less than. If y is less than, you draw a dashed or dotted line through the point and shade below. If y is greater than or equal to, you draw a solid line through the point and shade above now. If y is greater than, just greater than, you draw a dashed line through the point and shade above. Remember, you still have to flip the inequality when you multiply or divide, which you'll do more often, by a negative number. Do not forget that one key rule. All right. I'm not going to go through these because we just did 4 examples earlier, but this is the same thing. Actually, I take the back. Let me go ahead and go through it. I just want to go ahead and just give you as many views as possible on how to do this. Okay, so again, step 1 is solve for y if necessary, and here I do have to solve for y. So I'm going to subtract x from both sides. That's going to cancel, leaving me with y is less than negative x plus 2. Identify your y-intercept. So b equals not negative 2, but positive 2. Go ahead and graph that on your graph. 1, 2. Plot your point. Identify your slope. M is equal to, if you have a negative x, that means you have a negative 1. So m is equal to negative 1. And if you put this in a fraction, you put negative 1 over 1. That's your rise over your run. So I'm going to go down 1 this time and over positive 1 and do it again. Down 1 and over 1. Remember, back from first semester, okay, if you have a negative slope, your graph should be going in the downward direction. Now we're dealing with a less than sign. Okay, and again, I need to look at this. We're dealing with the less than sign only, so I'm going to draw a dashed line. Extend that graph all the way through. Put your arrows. Because y is less than, we're going to shade below the y-intercept. Here's our y-intercept, so shade below. Well, that's going to put us down here, and we just shade everything down here. Okay? And there's our inequality. Check to see if the points are valid. Do these points part of the solution? Let's look. Here's the origin. 0, 0. Is it a solution? Yes, it's in the shaded region. Let's go to 5 over. 1, 2, 3, 4, 5. Up 0. Plot a point there. Is it part of the shaded region? No, it is not a solution. 0 over and 2 up. 1, 2. This is on the line. Is it part of the solution? No, because the line does not count because it is less than only. All right. Next example. I need to solve for y, so I'm going to add x to both sides. That's going to cancel, leave me with negative 2y equals x plus 4. I've got to divide both sides by negative 2. Negative 2y, not equal, sorry, is greater than or equal to. X plus 4, divide everything by negative 2. This is going to cancel. Now, because I divided by a negative, I'm going to flip the sign, so now I have y is less than or equal to negative 1/2 x. Remember, this is like having a 1x, so negative 1/2 x. Okay, minus 4 divided by negative 2 is minus 2. So there's our inequality. Identify the y-intercept. B equals negative 2. Go ahead and plot that. Negative 2 on the y-axis. Identify your slope. M is equal to negative 1/2. It's already in rise over run for us, so we're going to go down 1 over 1, 2. Do it again. Down 1 over 1, 2. Now draw your line. Because it is equal to, we're going to draw a solid line. Make sure you extend it through the graph. And we're going to shade below again because when I flip my sign, it turned into y is less than or equal to. So I'm going to shade below. And there's my graph of this inequality. Let's verify if these answers are solutions or not. Go over 1 and up 4. 1, 2, 3, 4. Not even close. Not a solution. Not in the shaded region. Negative 4. 1, 2, 3, 4. Down 0. Well, that's on the line. Is that part of the solution? In this case, because it's equal to, then yes, it is part of the solution. Negative 1. Down 5. 1, 2, 3, 4, 5. Is that part of the solution? Yes, it is. It's in the shaded region. Okay. All right. And we'll get to our last page now. And again, I apologize for the length of this, but we are trying to make up for a one lost day. All right. Now, we are going to write the equation of the line. Rather than graph it, it's already graphed for us. So we need to write the equation of the line. Okay? So what is the equation of the line? Well, first of all, we have to identify our y-intercept. Because remember, we're in the form of y equals mx plus b. We need to find y equals blank x plus blank. Easiest thing to find first, the y-intercept. That's the where it crosses the y-axis. There, it crosses the y-axis at the origin. So our y-intercept is 0. Now we need to find our slope. Remember, our slope is, with 2 good points, rise over run. I have one good point, which is the y-intercept. I need to find another good point. And that is a point that goes directly through a crosshair. Okay? So right here is a good point. So what's our slope? Well, up 1, up 2. So rise, 1, 2. So our rise is 2. That's a positive 2. And our run is 1, positive 1 to the right. So our run is 1. So our slope is 2 over 1. If you reduce that, it's 2. So our equation is y equals 2x. Okay, again, that's not y equals, excuse me. Oh yeah, okay, yeah, y equals 2x. So I'm just getting the line. That's the line. Okay? Again, this is old stuff. You need to go back and review graphing. Go back and review graphing. Now it's asking, is the line solid or dashed? It's solid. We should start to formulate what that means in our head. Is the graph shaded above or below the y-intercept? Well, this is the y-intercept. It's below. So write the inequality that represents that. So we already know it's y something 2x, but what is our line going to be? Well, it's below. I'm sorry, what is our sign going to be? It's below, so that means it's going to be less than. It's a solid line, so it's going to be equal to 2x. So y is less than or equal to 2x. Okay, now we're going to do it all again without the steps. First thing, I want to find the y-intercept. Where's it across the y-axis? Okay, because I'm looking for y equals mx plus b, y equals blank x plus blank. Okay, the y-intercept is the easiest one. So, plot my point here. It's 1, 2, 3, 4, 5. My y-intercept is 5 up, so it's positive 5. My slope is rise over run again with 2 good points. So I'm going to find another good point. This looks like a good point right here. So I'm going to go up 1, 2. I'm going to go up 2. So my rise is 2, positive 2, and then I'm going to run 1, 2, 3. So my run is 3. So my slope is 2/3. Okay. Now I need to go ahead and put my inequality sign in there. So I know I'm going to have y something 2/3 x plus 5. Is it shaded above or below the y-axis, y-intercept? It's above the y-intercept, so that means y is greater than. Do I have a dotted or solid line? A solid line, so that means I just leave it as greater than. It is not equal to. So there is our inequality. You need to know how to do this too. Probably more important than graphing. All right, finally, let's do this one word problem and call it, or these 2 word problems, I guess. Zark is buying peanuts and cashews for a party. He can spend no more than $24. Peanuts cost $2 per pound and cashews cost $3 per pound. Let x equal the number of pounds of peanuts, and y number of pounds per cashews. So let's write the inequalities. Well, let's start with 24. He can spend no more than $24. So that means that everything on this side of the inequality sign needs to be less than 24, right? Over here is less than. So 24 is the max. That means 24 is greater than this side. Because he goes over 24, he can't spend that much money. So now I'm doing $2 per means multiply per pound of cashews. So cashews is y. So I'm going to do 2y plus, because I have to add those together to get a total cost, $3 per, again multiply, peanuts. Oh no, I'm sorry, I got it backwards. It's 2x, I was reading it backwards. So peanuts cost $2 per pound, so 2x plus 3y. So there's our inequality. Now, it says which of the following is a solution of the inequality. Okay, what I'm going to do is I'm going to, it gives you a graph so you can graph this, but I'm going to solve this algebraically. So what I'm going to do is this. I'm going to take my equation, which is 24 is greater than 2x plus 3y, and I want to solve this algebraically just to practice that skill. So I'm going to start with 2 and 8. So I'm going to put 24 is greater than 2 times 2 plus 3 times 8. So 24 is greater than 2 times 2 is 4 plus 3 times 8, which is 24. So 24 is greater than 28. Does that make sense? No, it doesn't. Okay, that is not the answer. So let's do this one. 24 is greater than 2 times 4 plus 3 times 6. So 24 is greater than 8 plus 18. 24 is greater than 26. Does that make sense? No, it doesn't. Okay? So that is not a solution. By default, by process of elimination, that should be our solution, but let's go ahead and work it out. 24 is greater than 2 times 8 plus 3 times 2. So 24 is greater than 16 plus 6. 24 is greater than 22. Does that make sense? Yes, it does. So C is absolutely our solution. So that is covering all that you need to know for linear inequalities at this point in time. It showed us how to graph. It showed us how to find the solution. It shows us how to check to see if solutions were correct. And it also shows how to write inequalities at the same time, write inequalities from the graph, and we also were able to solve algebraically. Again, if you need to rewatch this. I apologize it's so long, but I had to make sure I got all the information you needed. All right, I'll see you guys tomorrow.